All right, y'all. So 6.8 continued. And we've done most of the stuff we're going to do out of 6.8. So it finishes up with some new terminology, starting at question number 7. They start asking you about finding any relative maxima or relative minima from the graphs. So let me write those down. Relative maxima. All right, y'all. So a relative maxima, that's anywhere where you have any peaks in your graph. So that's going to peaks that occur on a graph. Okay, so it's little bitty parts where it's going to make a hump like a mountaintop. So the maximas will actually be the little peaks there, okay? All right, y'all, I gotta let me make sure. Is anybody hearing me on there?
I can hear you.
Okay, okay. Yeah, it must be your end, okay? All right, y'all, thank you. All right, y'all, so then a relative minima. So a relative minima is going to be little valleys that you get in the graph. Now, this might not be the overall minimum of a graph, but it'll be a minimum for a little section that might do a dip on it, okay? So for these, I'm actually going to pull up MathLab and have y'all sort of go through these with me, okay? So these start at y'all's number 7. So y'all let me pull that MathLab up. I want to make this graph larger. So really, this graph only has one. So they want to know, is that a relative maximum or a relative minimum? And that would be what, a peak? So that's a peak right there. So we said, remember, if it's a peak, it would be a relative maximum. So you would click the relative maximum, and it only gives you one check on that. Then it wants to know at what x value does it occur at, and what is the value? Well, the x coordinate of this point right here is going to be the x value that it occurs at. The y value is the minimum or maximum value, okay? So this would occur at x equals a negative 2.5. And y'all, they're actually giving you the point here in the parentheses. And then it would have a value of 3.25. Okay? And then we will check that answer. So let's see if y'all remember this. This we did the other day. So y'all on this, on what interval is my graph increasing? So y'all let me remember. Remember, mine is actually increasing on the left side here. Oh, good. I see it up there. I got some C's going. Yeah, because remember, it's coming in from negative infinity over here. And you're cruising down the x-axis until we get to this x value, which was negative 2.5. So we would go with C on that. And good job, y'all. Good job. So you know they're going to ask us for the decrease in next, right? All right, y'all. A, B, C, D for the decrease in where my graph is going downhill. Are y'all saying C again? Yeah, because C, let's see. Because on the x-axis, it's going to start where that and quit. So that and quit going uphill at negative 2.5, so it's going to start going downhill on the other side of that negative 2.5 as my x heads to infinity. Oh, yeah, good job. All right, so let me make this one a little larger for us. Whoops, I might have made it too large. All righty, so let's see. First of all, the relative maximum is, well, there's a relative maximum is that peak right there. So I want to know what value that is and then what x value that happens at. Well, the maximum value we said was the y value. So that's going to be the negative 1. So see, they're going in a different order on this one, y'all. Be careful. On this one, you got to put the max value first and then the x coordinate. And then it happened at that x value of 2. So watch MATLAB's a little tricky. The last one, we gave them the x first and then the value. On this one, you're going to give them the value first and then the x, okay? So be careful on that. So let's see what y'all do with the minimum. All right, y'all, so my relative minimum is blank at x equals blank. Well, that's that little valley right there. So let's see, that thing has a y value of negative 19, yep. And then it happened at an x value of, what's giving me that x value is what? Is that an 8 it looks like? Of 8. So usually on these ones, they're going to give you the point. You just got to figure out which one's the min or max, which one's the x value, okay? All right, y'all, let's see. It says continue. So now, increase in intervals, and you do have two parts going uphill. You got the left side going uphill, then it goes downhill, and then the right side's going uphill. But what's nice is they're giving me all the x values. So this first side where it's increasing, you're coming in from a negative infinity until we hit 2. So let me see. Someone's got that up there. Let's see. So Angela, let me see. So you're right on that first one. And then it looks like it starts at 8 and heads off towards infinity. So y'all, that is definitely D for us. So good job. All right, so you're going to check that answer. And then it's going to want our decreasing. All right, also decreasing is just that little middle section of the graph where it starts going downhill. So I want to know, where does that start at and where does it end? A, B, C, or D? So Carlithia, y'all are saying D. Looks like Angela's saying D. So let's see, that goes from what, 2 to 8. And y'all definitely, D is going from 2 to 8. So these problems are basically what we did Tuesday, other than they got a few problems of min and max stuff. So y'all look here, this has got A, B, C, D answers. They want to know any relative maximums or minimum. And they're giving you the answer here. So let's see, our maximum right here in the right on the y-axis is my maximum right there. That's got a maximum of 1 and x equals 0. So Carlithia, you're getting an A there. Let's see. So it's got a maximum of 1 and x equals 0. Good job. And then that minimum looks like a minimum of a negative 3 Add x equals 2 there. So you're perfect. That is definitely going to be an A. So it looks like if you can at least get the maximum here, you can narrow it down to 2, and then this one set around as the minimum of none, which was false on that, okay? All right, y'all. So this section finishes up doing the piecewise function stuff again. But now, instead of y'all picking out which equation we're going to use, we're actually going to evaluate it and get an answer here. So these will be 10 and 11 here. All right, y'all. So y'all got this piecewise function sitting here. They want me to find g of negative 7. So let's see. Let's write this down. We're going to find g of negative 7, g of 2, and g of 8. We're given g of x equals x plus 9 for x less than or equal to 2. And then we use 6 minus x for any x greater than 2. All right, y'all, so let me go back to my pad here. All right, y'all, you got these two equations, and they want me to find these three values. So I'm going to start with g of negative 7. So y'all, here's the question. To find g of negative 7, will I use the first equation or will I use the second equation?
First equation.
First equation, good job, y'all, because negative 7 is less than 2. All right, so that means we'll put a negative 7 in for that x. So y'all, that'll give me a negative 7 plus 9. So we just figure out what that is. Angela, you had that on there too, didn't you? Yeah, good job. All right, y'all, so negative 7 plus 9 is going to give me what? A positive 2. All righty. Which equation would y'all use to find g of 2? First equation or second equation?
You use the first one again.
It's going to be the first one again, y'all. Good job, because I got that equals under there. So that means 2 equals 2 is true. So we'll put a 2 in for our x. So we'll have what? 2 plus 9 for that one. Well, y'all getting 11. Good job. And y'all finally was g of 8. First equation or second equation?
The second one.
Second one. Good job, because my 8 is greater than that 2. So that'll give me a 6 minus 8 for that one, y'all. All right, so what y'all getting? Negative 2. Good job. Hey, y'all, so that's the trick on these. Find where your domains, your value fits, and then use that equation, okay? All right, y'all, so let me stay on this one. So this one, you're finding four things. You're going to find h of negative 10, h of 1, h of 5, and h of 8. Now this one, they're giving me three equations. H of x equals negative 3x minus 19 for any x is less than negative 5. It's going to equal 5 for negative 5 less than or equal to my x less than a positive 5. And then it's going to equal x plus 2 for any x that is greater than or equal to 5. All right, so we've got our domain there, our three equations. So we're going to find four values on this one, okay? All right, y'all, let me put this down just a little here. So what's first? H of negative 10. So would I use the first equation, second equation, or third equation?
The first equation.
First equation, good job. So I'm going to put a negative 10 in for that x. So I got negative 3 times negative 10 minus 19. Oh, y'all, what's that? Well, let me that one back in here. That's going to give me 30 minus 19. And then 30 minus 19, that's going to give me what, 11? All right, y'all, which equation for h of 1? So second equation, good job. Second equation, because that 1 is going to be in between this negative 5 and that positive 5. So you sort of got to think about a timeline on that. Now look here. Carnithia, good job. This one don't have a variable in this equation, so any value that's between this negative 5 and positive 5 is just going to equal 5. That's like a little constant section of your graph. Anything down there is going to be 5, okay? Almost like salary pay. All right, good job. Which one would y'all use for h of 5? Well, y'all got third one, good job. Because 5 is equal to 5. So I would use the x plus 2. So I'm going to put in a 5 for the x. And y'all, 5 plus 2 gives us a 7. All right, then I got one more, h of 8. So first, second, or third for h of
It's
8.
the third one again.
So third one again, good job. Um, Whoops, I'm down here. Because 8 is greater than 5. So I'm going to use this one, which says 8 plus 2. And y'all, that's what? 10, good job. Okay, so you take your number, figure out which one of these domains it fits in. Once you got that domain, you use them equations. And remember, on your second equation here, it's just a constant number, so that's what that value will equal if it's in between negative 5 and 5, okay? Alrighty, y'all, so now we knock out 7.5 in college algebra. So this deals with the graphs from the x squareds. Okay, so let me pull my paper back up. All right, y'all, 7.5. Analyzing graphs of quadratic functions. So remember, quadratic functions are my functions that look like this. Okay. Since these are x squared graphs, y'all remember they're either going to look like a parabola that looks like a U, or it might be a flipped over parabola. So y'all remember when I made the x squared term negative is when it flips them over, okay? Now, what we're going to be concerned with on these is what we call the vertex. So let me draw a little parabola real quick. Let's say mine is sitting over here at 3, and I'll have a y value of 1. So this little point right here is what we call the vertex. Okay, so the vertex is the point on the parabola that represents the minimum or maximum value. Okay, so the one we got drawn is a minimum value. If it was flipped over, then it would be a maximum value, okay? Now, there's things about this parabola. Notice, if I draw an imaginary line that cuts my parabola in half, this is what we call a line of symmetry. Now, an imaginary line that cuts the parabola into two equal sides. Okay, and remember, it's almost like being symmetric to the y-axis, y'all. I can take this parabola, fold it over that line of symmetry, and this right half will land on that left half there, okay? Now, we represent the line of symmetry as an equation. And we always do x equals some number. So for mine, if you notice, this imaginary dotted line crosses my x-axis at 3. So for the one I've got shown here, my line of symmetry would be x equals 3. So remember, those x values gave us the vertical lines, and the y's gave me the horizontal back in that chapter, okay? So that's why the line of symmetry is an equation equal to the x value of that parabola. All right, what else does this vertex tell us? Well, it's the point where we have a minimum or maximum. So it is the minimum or maximum value. So let me ask you all this. On the minimas and maximas I did a while ago, was it the X or Y value that told me those min or max values? Oh, y'all remember on those exercises a while ago for the minimas and maximas, we said what X value they occurred at, but the value that actually gave me the minimum or maximum value is equal to the Y values, okay? So this will be equal to the Y value of the parabola. Or I mean, have the vertex. So make that vertex there. So it's equal to the y value of the vertex. So for me, so mine, so the minimum on this one would be 1, like Angela got up there, okay? So look, x coordinate cuts it in half. The y value is the min or max value, okay? Now, here's the way to tell if you got a min or max. If A is positive, and y'all look up here for a second, A is the number in front of the x squared term. If this number is positive, you're going to get a U-shaped parabola, which means it's a minimum. So if A is positive, then you're going to have a minimum. If A is negative, so you got a negative x squared. If that A is negative, then it's going to flip it over and you're going to have a maximum. Okay? All right, y'all. So that's all that I know from that one little point. Okay? So we actually got what we call a vertex formula. Now, y'all remember, this vertex is an ordered pair. It's a point, right? So since it's an ordered pair, it comes in this form of parentheses. We always put our ordered pairs in parentheses. Now, to find the x value, you do negative b over 2a. So b, let me pull this down. B is the middle number, a is the first number. So you're going to pick numbers just like you did on the quadratic formula. So the x value is negative b over 2a. That's going to give me the x value. And to get the y value, we find f of negative b over 2a. So what that means is, once we know the x value, we plug it back in to the actual equation and find our y value. So this will give me the y value, which is either going to be the min or max, okay? So y'all, I'm about to play with some of these and sort of show y'all what we got going on, okay? All right, y'all, hang on one second. I'll let y'all write them. Um, the next one, I'm going to start out with a picture here, so let me get it to that. All right, y'all, so let me share this screen now. All right, I'm going to make this a little larger here. All righty, so on this one, for y'all's number one, don't worry about this ax minus h squared plus k. Um, they're just telling you that this is that graph, but they want me to find the vertex, axis of symmetry, and the minimum or maximum value. And y'all, they're giving me the vertex point here, okay? So all that is all I need to fill out these three questions. So the vertex, you're going to put your vertex in parentheses. And then let me pull that back down. Notice my vertex is right here, negative 3, negative 2. So at negative 3, negative 2 will be my vertex. And then close parentheses. So you're going to check that answer. The axis of symmetry. Now notice it says type an equation. Well, we said the axis of symmetry was equal to x equals one of these two numbers. Was it equal to the x value or was it equal to the y value? So y'all, what would y'all put? X equals what? So -2. Well, let's see, which one's my x value? My x value is actually the -3. So y'all remember, the axis of symmetry is x equals whatever the x value was, which was -3. Okay? Then you're going to check that. Now, what is the minimum or maximum value? That is what we said was going to be equal to the y value. And y'all, that y value looks like that looks like a -2. So on that one, you just put the -2. You don't put the y equals or nothing, okay? I just want the -2 on that one, and then you check that answer. So that first one, they gave you the picture, and they told you what the vertex was. On the rest of these, we're going to find it by doing the equations, okay? All right, also I'm going to go back to the pad. All right, y'all. So for these functions we're about to get, we're going to find the vertex. We're going to find the axis of symmetry, they call it. We're going to determine if minimum or maximum value. And find that value. And then they want us to graph it. Now to graph them, I'm just going to probably put them on my calculator, graph them, pick my 3 points, and be done, okay? But I'm going to tell you what, when you graph it, this section's a little pickier about the graphing, okay? Now my equation is f of x equals x squared minus 8x plus 7. All right, so we'll find all this and then we'll look at sort of what the graph will be, okay? But y'all, like I said, this one is really picky about what point you plot first. You got to plot the vertex first when we graph these, okay? So first of all, let's find that vertex. Now, here's my equation. We need to find A, B, and C. Since there's not a number in front of x squared, that automatically makes A a 1. B is in front of the x, so that's going to be -8. C is that last number, which is going to be 7. So now I know my vertex formula is -b over 2a, and then f of -b over 2a. So let me get the x value first. All right, y'all, the x value is -b over 2a. So bring down that negative. Just like on the quadratic formula, automatically you're going to write that negative. Now my b is at -8. So I'm going to have my negative and then that -8 over 2 times my a. Well, my a is 1.
Where did you get the in the F? Where did you get the -5 in the? Or am I
Yeah.
reading up? I'm just never mind. I'm
Oh,
blind.
that's a b. That should be.
I'm
So what?
sorry. I'm just
Uh,
blonde.
oh, this is all right. So what it means, Ella, is once I know what this negative b over 2a equals, then I'm going to find f of this number by using that equation. All right, y'all, so watch this. That negative negative makes that a positive 8. 2 times 1 is 2. And 8 divided by 2 gives me 4. So I now know what the x value is of this vertex will be 4. So now I want the y value of my vertex. I'm going to find f of 4. So that's what they mean by f of negative b over 2a. Whatever this equals, we'll find f of that right here. So f of 4 is going to equal 4 squared minus 8 times 4 plus 7. Okay, so whatever I got here, I plug it right back into this equation, okay? All right, y'all, so let's see. 4 squared, 4 times 4 is 16. Minus 8 times 4 is 32. Plus 7. So does 16 minus 32 gives me a negative 16 plus my 7. And y'all, negative 16 plus 7 is a negative 9. So my y value is going to be a negative 9. So this is what I would put in for my vertex, parentheses 4 comma negative 9. They want the axis of symmetry. Well, the axis of symmetry is going to be x equals what? What would y'all put there? Because we now have our whole vertex here. All right, good job. That's going to be x equals 4. Now, min or max. Is this going to be a min or max? Well, y'all, I look at A. A is a positive 1 here. Since A is a positive 1, it's going to look like a U. Carlithia, good job. It's going to be a minimum. And remember, it's a minimum because this A is positive. All right, so now, since it's a minimum, what is the minimum value? All right, good job. That's going to be a negative 9. All righty, y'all. So let me share Math Lab. So 4 negative 9 is my. All right, so that graph ain't going to match up with what I did, but I'm actually. Well, let me see. It might not let me graph yet. Ah. All right, so we'll just do these by hand. All right, y'all. So on your graph here, so y'all 4 negative 9. So let me go out about 10 at least. And I might have to go bigger. I'm not sure yet. All right, y'all. So Math Lab, here's the thing. You're going to choose the parabola tool, but this thing has 3 points on it. Now, it's very picky about the first point. First point we plot must be the vertex we found. So first point you plot must be the vertex. So for me, that was what? 4, -9. All right, y'all. So I'm going to go right 4 and then down 9. That's the first point I got to plot. Now, I'm going to use my calculator to find 2 more points. Okay, so let me share that calculator. Go to y equals. Put our equation in, which was x squared. Whoops, x squared. Then I had what? Minus 8x. And then plus 7. All right, y'all. So I need 2 points. So let me go to the table by hitting second graph. What's what it did not like? Oh, I put an arrow there. Let me delete that. All right, so now let me go to the table, second graph. All right, y'all, so I'm going to get down here by my vertex, y'all. There's my 4, -9 right there. So if I was going to get 2 more points, I'd probably get a point on each side of that. I'm going to do 3, -8, and then I'm going to come down here and plot 5, -8. So my other points are 3, -8, and 5, -8. Now, just to get a picture of what my graph needs to look like, I'm going to hit graph. And y'all, there's that parabola with that minimum y'all said. Okay. So, go back to the pad here. I've got my vertex here. So I need to do 3, -8. So write 1, 2, 3 and down to -8. And then my other point was 5, -8. So write the 5 and down to -8. Y'all, once you plot that point, it's going to come through and draw your parabola. Okay. All right, y'all. So these really aren't bad. Get those other points by just graphing it real quick, or you can find numbers and just plug them into that equation and get the y values that way. Okay. All right, y'all. So let me fix this back up. All right, y'all. So this one they're giving me f of x equals 2x squared plus 14x plus 23. So this one's like number 3. So this one, you're going to get fractions for the answers, okay? So this is like y'all's number 3. So A is 2, B is 14, and C is 23. All right, y'all, here's my formula again. Negative B over 2A, F of negative B over 2A. So I'm going to find my vertex first, and I'm going to start with my X value. So that's negative B over 2A, which will be a negative times that positive 14 over 2 times a positive 2. All right, y'all, so this time it changed that positive 14 into a negative 14. And then 2 times 2 is 4. So, y'all, I cannot divide 14 by 4, so I'm going to reduce this fraction. And it looks like both of these have, what, 2's in them? So 14 divided by 2 gives me a negative 7 on top. 4 divided by 2 gives me a 2 on the bottom. All right, so my vertex will have a x value of negative 7 halves. All right, so I got the y value. That's going to be f of a negative b over 2a. Whoops, which would be what? Negative 7 halves for us. So it's going to be f of a negative 7 halves. So that's going to be 2 times negative 7 halves squared plus 14 times my negative 7 halves and then plus 23. So y'all check this out. I will do this by hand, but if you're weak at doing this stuff, you can plug it right in the calculator like we got it right here, okay? So by hand, exponent first, and you got to square the top number and the bottom. So negative 7 times negative 7 is 49. 2 times 2 on the bottom is a 4. All right, I'm bringing everything else down. So the only thing I did was multiply negative 7 halves times negative 7 halves. All righty, now I'm going to multiply straight across. Now, there's not a number under 2, I make it like a 1. There's not a number under the 14, I make it like a 1. You're going to multiply straight across. 2 times 49 is 98 over 4. Right here you got 14 times negative 7. That's going to give you a negative 98. So that's like a minus 98. 1 times 2 is 2. And then plus my 23. Alrighty, y'all. So let's reduce this 98 over 4. Both of these will divide by 2. So dividing by 2, 49 divided by 2, 98 divided by 2 gives me 49. 4 divided by 2 is a 2. Minus my 98 over 2 plus my 23. All right, y'all, these two have a common denominator, so we can now subtract these two, okay? So 49 minus 98 gives you a negative 49 on top over 2 plus my 23. All right, y'all, I'm going to put a 1 under that 23 because at this point, I can't add these unless we find a common denominator. So bring down that negative 49 over 2. So the common denominator would be a 2. So we got to change the second fraction into something over 2. So 23 times 2 is going to give you a positive 46. 1 times 2 is 2. So notice if you're doing it by hand at this point, you had to find the least common denominator, okay? And my least common denominator, when you got a 1 and a 2, would have been the 2, okay? All right, y'all. Negative 49 and 46 now gives me a negative 3 over my 2. So that's going to give me my y value of my vertex. Now, y'all, on the calculator, like I said, at this point, you could have plugged that right into the calculator. It would have gave you a decimal, but turn the decimal back into a fraction and get that negative 3 halves. Alrighty, so that's your vertex. Axis of symmetry is going to be x equals the x value, which is negative 7 halves, Do I have a min or max? Is that A positive or is A negative? Well, let's see. A is way up here. A is a positive 2. So good job. It's going to be a minimum. And the minimum value is my Y value, which is a negative 3/2. And then y'all remember at that point, it's going to make you graph it. Now, we'll say this, since you're ending up with these halves on this one, they're going to put a mark in between each of these numbers. So I'm putting halves in between all my marks here, okay? All righty, y'all. So let's see. Vertex has to be first. And my vertex, remember, was -7/2 and -3/2. Now, if you want to graph these, you can turn these into a decimal. But -7/2 is like a -3/2. A -3 1/2 if you make them into mixed fractions. And -3/2 over here is like a -1 1/2. So watch this. -3 1/2. Come left over here, there's -3. There's -3 1/2. And then we're going to go down 1 1/2. So that'll be right here, -1 1/2. So that point should be right in here for my vertex. Now, getting the other 2 points won't be bad because I'm about to throw this whole thing into my y equals. And in y equals, I'm going to put in this 2x squared, 14x, 23, okay? So let's go to that calculator. I'm going to go y equals and clear this off. All right, y'all, we had 2x squared plus 14x plus 23. So let me graph it because y'all said this was going to be a minimum, so it should look like a U. And y'all, there's that vertex we just now plotted. Look here, -1, -2, -3 1/2. And then it going down -1 and about -1 1/2. Now, second graph to get a table. Because remember, I needed 2 more points. So I was at -3 1/2. So that's going to be in between that -3 and that -4. Now, this won't show the vertex point on here because everything's going by ones on the calculator, okay? But you just needed 2 points. So I would do -4, -1, and probably that -3, -1. Those are 2 points right around my vertex that would be easy to graph. So going back to my pad, I just got these 2 points from the calculator. So y'all, -4, -1 is right here. -3, -1 is right there. So then we would make that parabola curve up. Just remember in MATLAB, you're going to choose the parabola tool, plot the vertex first. As long as you plot the vertex first, these will give you all the right answers, okay? All right, y'all, so I'm going to do an easier one actually on MATLAB, okay? So let me see, is this one got a negative? Yeah. All right, y'all. So f of x equals a negative x squared minus 6x plus 7. All right, y'all. So the same thing. Let's go figure everything out. All right, so let's see. A is a -1 this time. B is a -6. And C is 7. So we're going to find our vertex, x value first. Negative B over 2A will equal a negative times -6 over 2 times a -1. Right, because my A is negative this time, so I had to put a -1 in here. So on top, negative times negative makes that a +6. On bottom, 2 times -1 is a -2. And y'all look at that. 6 divided by -2 is a -3. So the x value is -3. So we want our y value. That's f of -3. All right, y'all, but be careful. That negative's already there. So bring down that negative. Put in your -3, square that, minus 6 times -3 plus 7. All right, so exponent first. So bring down this negative. -3 squared is -3 times -3, which makes that a 9. -6 times -3, that's going to make this a +18. And then at the end is a +7. If y'all notice, this second number is always opposite and signed in the first one, and it's always double it. Okay, so every one of these I've been doing, the middle number is twice as big as this one and opposite in sign. So -9 and 18 is a +9 plus 7.